So in the previous video, we introduced the equations for calculating freezing point depression and boiling point elevation. Both of those equations involve the concept of molality. So it's very easy to get these two terms confused, molarity and molality, because they both have chemists' favorite unit, the mole, in them. Molarity, which is something that we've talked about previously when we talked about solution stoichiometry and in the titration lab. Molarity, which is designated by capital M, calculating molarity is moles of solute per liter solution. So it's moles per volume in liters. Molality also has moles of solute in the numerator, but in the denominator, the volume is not liters, but kilograms, and it's specifically of the solvent, or the mass of the liquid. So that's how you calculate molality, and that is the concentration form that is used in the boiling point, elevation, and freezing point depression problems in this section. But let's first do an example problem of calculating molality. So if I wanted to know what the molality of a solution is, by dissolving 7.6 grams of urea, I don't give you the formula, but I do give you the molar mass. So I have some solute, and I dissolve it into some amount, 150 grams of water, and I want to know what the molality is. Well, molality is moles of solute divided by kilograms of solvent. My solute is the urea, so I need to take my grams of urea and convert it into moles by using the molar mass, written appropriately so my grams cancel. So doing that multiplication and division, I get that many moles of urea. So that will go in the numerator, but I got to find out how many kilograms of solvent of water I have. I gave you the amount in grams, so I need to convert that to kilograms by remembering our powers of 10 from way back in chapter 2 or 3. I can convert my grams into kilograms. 1 kilogram is 10 to the 3 grams. Doing that multiplication and division, I get 0.150 kilograms. Now I'm ready to calculate my molality. So I take my moles of solute, divide by my kilograms of solvent, and that gives me a molality of 0.87. So that's how you calculate molality. It's moles specifically of the solute divided by kilograms of the solvent. In the final video for this chapter, we're going to talk about how to, again, we'll review how to calculate molality and then how to use that to find the freezing point depression and the new freezing point of a solution.